Dear Doctor, I'm Shen Qihui and thank you for your watching. Today, I will present my research titled Housing Price Production Based on Machine Learning, a case study of Jinan. This study uses machine learning to build a price production model for houses in Jinan, a fast-developing city in eastern China. We use both traditional data like house size and location and modern features like street image analysis to improve production accuracy. This study aims to predict housing prices using multiple data sources and machine learning models. We collected over 1,000 second-hand housing listings in Jinan and added map data and street view images. Several models were tested, including XGBoost, LightGBM, and Random Forest. We found that XGBoost achieved the best performance with an R-squared of 0.92. The study contributes to smart city housing research by showing that precipitation-based variables like green view and building density play an important role in pricing. These insights can help home buyers, sellers, and urban planners make better decisions. China's real estate market is changing rapidly, especially in second-tier cities like Jinan. Many factors affect housing prices, such as distance to subway, local schools, and green spaces. Traditional statistical models often fail because they cannot capture complex, nonlinear patterns. In addition, past studies mostly focus on Tier 1 cities like Beijing or Shanghai. There is also a lack of research using street-level precipitation data. For example, what people see and feel in the environment. This study addresses these gaps by combining new data sources and modern machine learning techniques. The research had 4 goals: to build accurate housing price prediction models using machine learning, to develop a rich dataset that includes not just house listings, but also map data and street images. 3. To compare model performance and select the best one. 4. To identify which features such as structure, location, or street view have the strongest influence on price. These objectives help us not only predict prices, but also understand what really matters to buyers in Jinan. We collected data from multiple online platforms, Anjuke, Beike, and Google Street View. In total, we gathered over 1,000 resale housing records. Each data point includes 3 types of features: structure features like size, floor, and year built; spatial features like distance to subway, schools, and city center; precipitation features such as greenery, building density, and street cleanliness, extracted from street images. This multi-dimensional dataset allows us to build more powerful models than previous research. Before building models, we cleaned and processed the data. Missing values were filled using averages are removed. Outliers were hunted with the AQR method. Housing prices were log transformed to reduce skewness and help models learn better. Categorical features like district names were one-hot encoded. Finally, we checked for multilinearity using VIF. These steps ensure that the dataset is clean, balanced, and ready for training. We tested 6 different models: multiple linear regression, 2. K-nearest neighbors, 3. Random forest, 4. GBDT, 5. LightGBM, 6. XGBoost. We split the data 80% for training and 20% for testing. To compare performance, we used three key matrices. R-squared, how well the model explains variation in price. MAE, a average set of areas. MAC, how large the areas are, especially big ones. These models let us test both traditional and advanced machine learning approaches. The best model was XGBoost with an R-squared of 0.92, a MACE of around 4,000 and a MAE of about 2,100. This means the model can explain 92% of the changes in housing prices. Other models like linear regression and KNN had much lower accuracy. In the scatter plot of protected vs extra process, XGBoost shows a strong linear pattern, meaning the predictions are close to real values. This proves that machine learning, especially XGBoost, can effectively handle complex housing data. XGBoost also helps us understand which features matter the most. The top 5 variables were 1. House size 2. Green view from the street 3. Distance to subway 4. Building density 5. Commute time to city center. This shows that both physical features and what people see and feel in the environment strongly affect housing prices. In fact, some perception variables were more important than location itself. This study shows that using both normal data and street view data helps make better house price predictions. Machine learning, especially XGBoost, can find hidden rulers that old models cannot see. Things like green streets, clean areas, and short travel times can make a house more expensive. This gives us a new way to look at housing not just with numbers, but also with what people like and feel. The model can help city workers, wholesalers, and buyers make smarter choices. In the future, we can use this idea in other cities and maybe use stronger models like deep learning. Thank you for listening.